Hey everybody, I'm Mr. Calbeck for Calbeckistan, a place where anybody can learn math. Today we're going to be starting our series on solving. Okay, this is the first crash course episode. We're going to be talking about the basics, the concepts, why things work. If you are starting the crash course series, I'd recommend that you begin with this first video. Even if you can skip the next 3 or 4 before you get to the hard stuff, I'd recommend that you still start with the basics, because once you understand the concept, everything else is going to be based on that. Here's what we're going to be looking at. A very simple case. Something like this. 3 plus x equals 7. And some of you are already looking at this and you're like,
now Calbeck, I don't like having, I don't like letters in my math. I was great at math until you put the letters in. Don't like that.
If that's you, take comfort. This is not a letter. This is an English class. We're not spelling things. This actually, mathematicians a long time ago realized that when we don't know a number, it's easier to represent it with a letter. What we could have done is written it like this. We could have said 3 plus blank equals 7. All right, 3 plus blank equals 7. That's harder to write. It's harder to do math with. So what we started doing is we said, hey, what if I just replace this with a letter? Usually we use X. You can think of it as X marks the spot. But this could be any letter. It could be A, it could be X, it could be W, Y, Z. Sometimes in more advanced math, you'll even use letters in other languages. Like you might use theta. That's a Greek letter. Okay? So you can use letters in anything, and it doesn't even matter. Again, we're not spelling words. All we're doing here is we've got a blank. Okay? And so if you ever see a letter in math problem, it's not a letter, it's a number. All right? So get that out of your head. It's not English class. These are not letters. This is a number. Okay? So start with that. So once you realize that this is just a blank, a lot of you are just right in your head, you're like, oh yeah, I know what that is. It's 4. And you're absolutely right. That is 4, and I'm honestly super glad that most of you can do that in your head. That's some great mental math skills, and that'll really serve you well. However, in this video, in this series, I want to teach you to think about this in a different way. Because once you are depending on this method where you just kind of see the answers, it's going to get really hard, really fast to be able to do this entirely in your head. So I want to think about this in a different way. All right? So we're going to go to our next thing. What does it mean when we are solving something? And what it means when you're solving something is that you want to get the variable by itself. I want to know what the variable equals. So I want to know what the variable equals. I want to get the variable by itself. But that actually makes things a little bit challenging because there's this pesky 3 here. So I want to break this down even more, and I want to talk about what does this equation actually mean? What does it mean when we have an equation? What is an equal sign? What does it actually do? And an equal sign, again, a lot of teachers don't ever talk about this, and you were raised in elementary school, and your teachers probably taught you that equal sign means the answer. Like you were given problems like this. You'd have 1 plus 9 equals, and so you'd have a blank here, and so you were taught that equal sign means answer. The equal sign does not actually mean answer. What the equal sign means is the same. It means that these two things are the same. Whatever is over here is exactly the same as what's over here. And you can see that here. 1 plus 9, you know that, is the same as 10. So an equal sign is the same. Sometimes when I'm teaching classes, I will talk about this as being a balance beam. So let's draw this differently. Let's think about the equal sign. Instead of it being the answer, let's think about it as a balance beam. So I'm actually going to draw a balance beam here. So I've got that equation, and I've got 3 things over here. Maybe I've got 3 little guys right here, 3 boxes. And there's this other mystery thing, and I don't know what it is. I don't know how much it weighs. Maybe it's like a bag of something. We'll call it X. So I've got 3 things, and then a bag, and I don't know how much that weighs. And over on this side, you got 7 things. Okay, so I've got 7 things over here and 3 things over here. It's a balance beam. I also tell my students that underneath this balance beam is a lake of fire. So, I want to make sure things stay balanced. And my goal is, I want to know how much this X, this bag of stuff, weighs. And again, this is just exactly the same as what I'm talking about here. This is 3 plus X equals 7. There's 7 things over here. And then 3 and X things over here. And I want to know how much that bag of X weighs. Does that make sense? So I want to get just this bag on one side, and I want to have the number of things over here. So if I want to keep this balanced, I have to be really careful, right? I can't just take these 3 things away, because then suddenly it would tip over here, and very quickly all of your stuff is going to fall into the lava. All of your blocks here are going to fall into your lava. And you can see them, they're just burning up, and then this is going to fall into the lava. Oh man, this is just all sad. Suddenly everything is burning and everyone dies. You don't want that, okay? We don't want that at all. Instead, we want to keep everything totally balanced. So let's go back before we made everything burn. All right, so if I want to get just the X by itself, I need to take away these 3 things here. So I can have the X on one side of the balance beam and the weights on the other side. But if I want to keep it balanced, I need to take these 3 away, and I need to do the exact same thing over here. So if I'm removing 3, suddenly this weighs more. But if I take the same amount away from both of them, say I take 1 away, I have to take 1 away over here as well. If I take all 3 away over here, I need to take the 3 away over here. All right, and so now you have the X by itself on one side equals the 4 blocks left. Okay, I want you to think about that. Think about the equal sign being a balance beam rather than an answer. So let's see what this looks like in terms of the actual math. What I did here is I said, okay, I want to take 3 away. I want to subtract 3 from this side. And I want to do the same thing over here. As you're doing your math problems, I want you to be working down the page. Okay? One of the biggest reasons people make mistakes in math is they're not organized. I'll talk about that more in later videos, though. Okay, so what is 3 minus 3? That's a 0. Nice. Okay, there's no boxes left, and usually we don't even bother to write zeros when we're adding them. That leaves me with just an X over here. Bring the equal sign down because it's still there. That's still balanced. And then I say, what's 7 minus 3? It's 4. So now I know exactly what the X equals. It's X equals 4. Okay, please put a box around your answers for your teacher. They'll really appreciate seeing that. And that's the idea. If you think about the equal sign being a balance beam, and whatever you're doing to one side, you must do to the other side. You're going to be in great shape. Okay? In fact, this whole concept of doing the exact same thing to both sides, because you're trying to keep it balanced, it's the golden rule of math. Okay? So the golden rule of math goes like this.
That which you do to one side, you must do to the other side.
Whatever you do to one side, you must do it to the other side. If you follow that rule, you can do anything that you want in math, and you won't make a mistake. All right? Tune in next time. We're going to talk about more specifics on how we actually solve different kinds of problems.